Assalamualaikum and hi everyone. Today's topic is about reliability. Okay, when you have a measurement, the next step is to determine whether your measurement is reliable or not. Okay, so what is the meaning of reliable? Reliable means that the item that you construct can measure the dimension consistently. Okay, if you have an instrument, okay, or you have tools to measure, okay, the tools that measure the item, okay, should measure consistently. Okay, so you should get the same result each time you do a measurement. Okay, for example, a weight, okay, or you took a blood pressure. Okay, so when you took a blood pressure, okay, for first attempt, second attempt, the third attempt, you're supposed to get the same result. Okay, if you do not get the same result, okay, meaning that the instrument or the tools to measure the variable, okay, are not reliable. Okay, a measure is reliable to the degree that it supplies consistent result. Okay, if you get a consistent result, okay, then the measurement is reliable. Okay, reliability contribute to validity but not sufficient condition for validity. Okay, so how does the reliability relate to the validity? Okay, example, okay, if the machine can measure your weight correctly, okay, for example, let's say your weight is 45, okay, and then the machine measure your weight 45 correctly, okay, then it is both reliable and valid. Okay, if it consistently weighs you by 2 kg, okay, overweigh you by 2 kg, maksudnya let's say actually your weight is 45, okay, but the machine weigh you 47, okay, and then each time you measure your weight, okay, the machine keeps consistently, okay, give the value of 47, okay, then the scale is reliable but not valid. Okay, and then if the instrument keeps doing error from time to time, okay, maksudnya kali pertama you naik berat 45, kali kedua naik 50, okay, berat kali ketiga naik 47. Okay, so the instrument keeps doing error from time to time, okay, then it is not reliable, okay, and therefore cannot be valid. Okay, so a measures, okay, supposed to be stable. Okay, if one can secure consistent result with repeated measurement of the same subject or respondent with the same instrument. Okay, so therefore we need a measurement that is stable, okay, so that we can get a consistent result. Okay, so how to get a stable measure? Okay, the first one is by conducting test, retest, reliability. Okay, so how to do test, retest, reliability? Okay, you can repeat the measurement using the same instrument under as nearly equivalent condition as possible. Okay, maksudnya dekat sini, okay, you ask the respondent to ask the same question, okay, to see whether the answer is consistent or not. Okay, the result of two administration are then compared and the degree of correspondence is determined. Okay, so we want to see whether is there any difference or not. Okay, for the first time answered and the second time answered. Okay, the greater the difference, the lower is the reliability. Okay, if the respondent give a different answer, okay, pagi katakan dia jawab lain, petang dia jawab lain, okay, so meaning that the measurement is not reliable. Okay, The problem with test-retest reliability, some item can be measured only once. Okay. And then the retaking of a measure may produce boredom, anger, or attempts to remember the answer given in the initial measurement. Okay, sebab you ambil information, you took the information twice. Okay, mula-mula dah ambil and then the second time ambil lagi. Okay, so the respondent might be bored, okay, and then anger because you ask the respondent to answer the same question twice. Okay, it took their time, okay, to answer the question. Okay, and then maybe the first attempt and the second attempt will be different because of the emotion. Okay, and then factor extraneous to the measuring process may cause shift in the characteristic being measured. Okay, extraneous factors could be masa lah. Okay, maybe there is a difference if the respondent answer in the morning and at the evening. Okay, or there's also a difference. Okay, if the respondent answered during busy time or free time. Okay, so the factor extraneous could shift the characteristic being measured. Okay, so the second way to measure the stability is the parallel from reliability. Okay, parallel from reliability used to assess the consistency of the result of two tests constructed in the same way, okay, from the same content domain. Okay, so we create a large set of questions, okay, that address the same construct, and then randomly divided the question into two sets and administered both instruments to the same sample of people. Okay, and then the result of the two administration are then compared and the degree of the correspondence is determined. Okay, the greater the difference, okay, the lower is the reliability. Okay, so in this case we have two sets, okay, of instrument, okay, but constructed in the same way. Okay, and then it have the same context. Okay, so if there is a difference between one set to the another set, okay, so we can see that the reliability is low. Okay, if there is not much difference, okay, between from one set to the other set, so we can see that there is no the measurement is reliable. Instead of measuring the stability of the measures, we also need to determine the internal consistency of the measure. Internal consistency of the measure is indicative of the homogeneity of items that measure the construct. The items should hang together as a set and be capable of independently measuring the same concept so that the subject attach the same overall meaning to each of the items. Okay, for example, let's say you want to measure about the level of satisfaction. Okay, so there are 5 items. Okay, so these 5 items should be correlate to each other to measure the level of satisfaction. Inter-item consistency reliability will measure the degree to which different items measuring the same construct attain consistent result. Okay, and then score on different items designed to measure the same construct should be highly correlated. Okay, as mentioned. So the item should be highly correlated in order to ensure that this item can measure the dimension of interest. In this case, we use the Cronbach coefficient of alpha. Okay, so for demonstration, okay, in SPSS, I use this online shopping habit. Okay, actually this is the questionnaire that I adopt from the internet. and this is about the online shopping habits. So there are 4 items that measure the online shopping habit. So this is the item. Okay, and then they are in a Likert scale. Okay, from strongly disagree to strongly agree. Okay, so to do that, okay, you can go to analyze, okay, and then choose scale, and then go to the reliability analysis. Okay, so in items here, okay, you include all the measurement that measure the online shopping habit. Okay, which are the items, okay, from S1 until S14. So there are 14 items that measure the online shopping habits. Okay, and then from here you can go to the statistic and then choose items, scale, and scale if item deleted. Okay, so we want to see the Chromebug Alpha if a specific item, okay, deleted from the measurement. Okay, continue and then okay. So this is the Chromebug Alpha value, which is equal to 0.658, okay, which is less than 0.7. Okay, a good or reliable measurement if the Chromebug Alpha greater than 0.7. Okay, and then in this case, since my number of sample size is quite low, okay, which is 33, there is possibility that my Chromebug Alpha is not greater than 0.7. So you might have to collect more data set, okay, to get more conclusive result. Okay, and then it also produce the mean and the standard deviation for each item. Okay, and then the item total statistic. Okay, where it also compute, okay, the Chromebug Alpha if the item deleted. Okay, for example, let's say if you delete this item, shopping on internet save time. Okay, the original Chromebug Alpha is 0.658. Okay, so after you, let's say you want to delete the shopping on internet save time, okay, the Chromebug Alpha is 0.661. Okay, so there is an increment, a slight increment, okay, from the original one. So if there is a slight increment, I think you don't have to delete this item. But if there is a significant difference, okay, from the original and the Chromebug Alpha after you delete that particular item, okay, then you might to consider to remove this item from the measurement. Okay, so in general, this is how you can interpret the Chromebug Alpha. Okay, in this case, the alpha value is moderate, okay, less 0.7. Therefore, the 14 items are less consistent, okay, and thus less reliable for measuring online shopping habit score. Okay, so if the item, okay, that you construct are not reliable, okay, is less reliable, what you can do is you can run factor analysis. Okay, so factor analysis will discriminate each of the item according to the category. Okay, I will explain in detail later on about the factor analysis. So this is the result of the Chromebug Alpha. Okay, in the Chromebug Alpha, okay, there are two things that you need to highlight here. Corrected item total correlation, okay, which indicate correlation between each item and total score. Okay, so if it's less than 0.3, so it indicates that's a low value, okay, which it measuring something different from the scale as a whole. Okay, and then if it is too low, you can remove the item, this one. Okay, 0.1, 0.169, okay, negative 0.06, okay, so this is very small value, less than 0.1. 3. Okay, you might want to consider to remove this item. Okay, but before you can remove the item, you need to do the factor analysis. Okay. And then Chrombar alpha, if item deleted, measure the impact of removing each item. Okay, if the value is higher than alpha, then we may consider to remove the variable. Okay, as I mentioned just now. Okay, so how to report? Okay, you can say that the items for online shopping habit score are moderate reliability. Okay, all Chrombar alpha is 0.658. Okay, so that is how you report the Chrombar alpha. Okay, the second way to measure the internal consistency, okay, is by using the split half reliability. Okay, split half reliability reflect the correlation between two halves of an instrument. Okay, the two halves can be created by splitting the item in the following way. Okay, odd and even numbered item. Okay, first and second half. Okay, or you arrange your item randomly. Okay, if the results of correlations are high, the instrument is said highly reliable in an internal consistency sense. Okay. So that's all. Thank you.